Hello, dear friends. Welcome back to Booty Aviation Training. SK Booty here. And today I will try to make your life easy in a complicated subject called gyros. Many people say that their brain topples when they start touching or doing gyro numericals. Well, no more. Pay attention, get your notebook, pencil, paper ready, and let us find out how to solve gyro numericals, and promise you they are not difficult at all. Try it out now. Remain with me. And here we are. How to handle the gyro numericals. There are primarily two instruments which have numericals, that is turn and slip indicator and directional gyro indicator. Let's sort out turn and slip indicator, also called turn coordinator or turn and balance indicator, a two-in-one instrument which shows you the rate at which you are turning and is your turn balanced or not. There is a spirit level ball. When you are turning right and the ball also goes to the right, you are slipping, which means you have given extra bank angle. Reduce the bank angle or increase rudder. You are turning right, but the ball has gone to the left, which means aircraft is skidding and you are given excessive rudder. If necessary, decrease the rudder or increase bank. Generally, you should prefer to play around with the rudder because bank you should avoid playing around with if you are flying at a particular rate of turn. If I am flying at rate 1 turn and your needle is showing you at rate 1, it is pointing at rate 1, that means you are turning 180 degrees per minute or 3 degrees per second. Half standard rate, you are turning at 1.5 degrees per second. Rate 2, 6 degrees. Rate 3, 9 degrees, etc. Most of your civil aviation flying will be at rate 1 or less. We don't give excessive banks. You are carrying passengers. And for rate 1, your bank angle should be true airspeed by 10 plus 7 degrees. If your true airspeed is 120, 12 plus 7, 19 degrees should be your bank angle. Bank angle and rate of turn are also related. Theta bank angle, not numerically, but concept-wise, it is directly proportional to the true airspeed and inversely proportional to the radius. Here is an aircraft turning at a certain true airspeed, and this is his radius, and he is completed 180 degrees. If your speed is more for the same angle of bank, then your radius will become more. When the radius becomes more, rate of turn falls. Okay, so much so. Let's get on to the numericals now. The total turn will be the rate at which you are turning into the time you are taking. If you are turning at rate half, you are turning 1.5 degrees per second, and after 1 minute, you would have turned by 90 degrees. For example, 330-2060 is 90 degrees. Or a left turn, readings will decrease. On a right turn, readings will increase. If you are told from 060 turn left by 90 degrees, immediately you like to know at what heading should I come out. Okay, 060 minus 90, problem? No problem. Add a 360 here, it becomes 420 minus 90, roll out at 330. Great. Time required to turn, if you are asked, how much time do you need to turn? then it is the total turn involved divided by the rate. For example, if you are turning from this 330 direction, turning right onto 120, it will be total of 150 degrees. 120 is also equal to 480. 330 plus 150 is 480. So 150 divided by 6 degrees per second, if you are turning at rate 2, you will need only 25 seconds. At rate 1, you will need 50 seconds. Or the other way around, if you are turning 150 degrees and taking 50 seconds, then you are turning at rate 1, 3 degrees per second. So out of these three, 2 are known, third can be calculated. Remembering always when you turn right or starboard or clockwise, readings increase. When you turn anti-clockwise, readings decrease. You can find out the time required to turn, how many degrees will you turn at a particular rate and in particular time. And these are types of numericals. And I will give you a question bank in one of the later sections to try out those questions. And second set of questions are related to the directional gyro indicator or direction indicator. It's a gyro instrument, and gyro has got a property of rigidity. If I'm at this place and I align my gyro with the magnetic north, now my DI and the magnetic compass will read the same. Now, what happens over a period of time, if those of you have flown, your instructor must have told you, keep aligning your gyro every 15 seconds. Okay, why should I? Because your gyro north gets misaligned. But gyro, we told, is rigid. Yeah, it is. Let's say I've started from here, and this is my magnetic north and gyro north. Over a period of time, Earth will rotate at the rate of 15 degrees per hour. And this meridian, same meridian, will now land up here. Meridians travel towards east, west to east. Now, after 1 hour, this is the 15 degrees angle, and my gyro, my meridian has turned. Now at this place, this is the aircraft heading. Gyro is still pointing in the same direction. This will be my gyro reading, which will be less than the magnetic compass reading. So we say the gyro has drifted, but has it? It is still pointing in the same point in space, and that is its property. So what has happened? Your magnetic north shifts. And when we say gyro has wandered or drifted, it is not the gyro. We'll call it apparent wander. Like you all know, you say the sun is now moving to this place, sun has gone to this place. Has sun ever moved? That is called the apparent movement. And here also we will call it apparent drift or wander. And it can be calculated for a particular latitude by a formula 15 into sine of latitude per hour. 15 degrees into sine of latitude, and remember this is per hour. Write down so many degrees. If you are in the northern hemisphere, write down gyro readings will decrease. If you are southern hemisphere, write down gyro readings will increase by this amount. In the southern hemisphere, this is your gyro north parallel to this place, but now my magnetic north has moved to the right. Here my magnetic north moved to the left. So here what will happen, this is the heading of the aircraft. Magnetic compass reading will be less and gyro reading will be more, and we'll say in southern hemisphere, gyro readings increase. Now, there are aircraft in which you can do a setting on the latitude nut, and that is called a balanced gyro. And if the latitude nut is same as the latitude over which you are flying, then you need not reset your gyro every 15 minutes, provided you are flying over the same place. And if you have set the latitude not to balance it at some other latitude, but you are now flying at some other latitude, then still there will be a wander. Let's take this case. Aircraft is at 30 north, but the latitude nut has been set at 45 north. Why should you do it? Don't do it. It's only a theoretical question. If your aircraft is at 30 north, there's no reason why should you set the latitude nut to 45 north. Okay, mistake has been made. Now what will happen? Apparent wander due to Earth rotation will be 15 into sine 37.5 degrees and write down degrees. The real wander created by the latitude nut, it actually moves the gyro axis in the other direction so that your gyro readings remain aligned with the magnetic compass. So the job of the latitude nut in the northern hemisphere is to increase gyro readings. But what have you done? You set it at 45 north. So 15 into sine 45, 10.65 degrees, the readings will increase. If you had set it at 30 north, then these two would have been equal. Net wander or remaining wander would have been 0. But in this case, there is still a remaining wander, which is algebraic sum of these two. So 10.65 minus 3.5. Since increase is more, I will write on that my gyro readings will increase by 3.15 degrees. Now, if you are flying in the northern hemisphere and latitude nut is also set to the same place, but instead of north, if you have set it south, damage is done. In the northern hemisphere, gyro readings will decrease by 7.5 degrees, and you have set the latitude nut to south, they will further decrease by 7.5, and now your error will become 15 degrees decrease. If both these are decrease, add them up, or increase, add them up and write down decrease or increase. But if one is decrease, other is increase, then find out the difference, and whichever is more, that will be your net result, net wander. If these two are given to you, aircraft is flying here, but there is still a wander, then find out the value of part 2. If it is increase, that means you have set the latitude to northern hemisphere. If it is decrease, you set it to southern hemisphere. And how much is the degrees? 15 into sine of which latitude is giving you this increase or decrease. Nothing very difficult. Try your 2 or 3 numericals and you would have captured the so-called dreaded numericals of gyros. I will give you some for practice in one of the later lessons. And if you like to keep seeing my later lessons, don't forget to like also and share my videos with your friends, as also subscribe to the channel. Good luck, all the best, and I'll be soon back with you for a quick revision, provided you have understood these two. For quick revision, last day revision, as also I will give you a question bank. Bye-bye for the time being. Good luck, all the best, and happy landings.